Welcome back to another exam walkthrough. We're going to be doing October and November 2025, paper 2-4 from Cambridge Physics. And we've got a question on projectile motion here. I want you to pause the video, try out the question yourself. And for the mark scheme, you can go to the end of the video. A child kicks a ball so that it leaves the horizontal ground with the velocity of 28 meters per second at an angle of 34 degrees to the horizontal as shown in figure 1.1. Air resistance is negligible. The ball leaves the ground at time t equals 0. Calculate the horizontal component and vertical component of the velocity of the ball immediately after it has left the ground. Okay, so that is pretty simple. You have the horizontal component, which is going to be 28 cos 34. And then you have the vertical component, which is going to be 28 sine 34. Okay, a quick tip on getting these always right is that the side that's making the angle with the resultant is going to be cos and the other one is going to be sine. Okay, so basically where the angle is, that's where you're going to be putting the cos. The other side will be sine. Now for example, let's take it, this is going to be the initial resultant velocity v. Let's put it u actually, u. Okay, and we're going to have two components here and this is going to be the angle theta. So in this case, students would go and say this is going to be u cos theta and this is going to be u sine theta, but it's actually the other way around. Okay, so this is going to be u sine theta and it's going to be u cos theta. Okay, so just be on the lookout of where the theta is, between what two sides the theta is, whether it's between the vertical and the resultant or whether it's between the resultant and the horizontal. Okay, that basically tells you where the sine and cos go. Okay, so I've plugged in 28 sine 34 and 28 cos 34 in the calculator, got 15.66 meter per second and 23.2 meter per second, and wrote them both in 2SF, so that gives me 23 and 16 for the horizontal and vertical velocity. Okay, in the next part it tells us show that the ball reaches its maximum height at time t equals 1.6 seconds. So we're going to use SUVAT for this, SUVAT. One more very important thing, we're going to say up is positive and down is going to be negative. Very important. Okay. Now, we don't know what the displacement is at the maximum height. We know the initial velocity in the vertical direction is going to be 16. And remember, this is our starting point. Then we reach maximum height. And there's a very special thing that happens at the maximum height to our vertical velocity. Our vertical velocity becomes equals to 0. Okay, so this is going to be 0. Acceleration due to gravity, minus 9.81. T is going to be question mark. So we just need a good equation for this. That's going to be V is equals to U plus AT. So 0 is equals to 16 plus minus 9.81 T. So T is going to be equals to 16 over 9.81. And that's giving me 1.63 seconds, which is approximately 1.6 seconds. Okay, so that's going to be part II. So part III, it says on figure 1.2, sketch the variation of the horizontal velocity with time t between t equals 0 and t equals 3.2 seconds. Label your line h. Okay, so we know that in the horizontal direction, the acceleration is equals to 0. So the velocity will be constant throughout the projectile motion. And we know the horizontal velocity is going to be equals to 23 meter per second. So we have 22, 24, 26, 28. So between 22 and 24, we're going to draw a straight line and we're going to label it H. So in the final part, it says on figure 1.2, sketch the variation of the vertical velocity with time t between t equals 0 and t equals 3.2 seconds. Assume that the velocity in the upward direction is positive and label your line V. So our initial velocity in the vertical direction is equals to 16 meter per second. So at t equals 0. Then we know at t equals 1.6 seconds, our velocity, let's call it V1, 1.6 is going to be 0 meter per second. And then our final velocity, we don't know this, at t equals to 3.2 seconds. We got to find that out. So we know that the ball is going to be launched, it's going to reach max height, and that's going to fall down. Okay, so it's going to be A, let's call this B, let's call this C. So I want to find, or rather I want to focus on the part B and C, that specific part of the projectile motion. Let's say this is our initial and this is our final. So we know that at the initial part, our u here in the vertical direction is going to be equal to 0, and v in the vertical direction is going to be question mark. Okay, so we can use SUVAT question mark. This is going to be 0 question mark minus 9.81. Now for the time, there's a very cool thing here. This part of the projectile motion, so to go from A to B, it's going to take us 1.6 seconds. And to go from B to C, it's also going to take us 1.6 seconds. I'll explain this a bit more. Just give me a little bit of time and let me calculate the final velocity. Let me calculate this and then I'll explain why this is true. So let's put 1.6 here, and we're going to use the equation V is equals to U plus AT. So V is going to be equals to, this is cancel out, 0 minus 9.81 and 1.6. You're going to get the answer as minus, if you round it to 2 SF, you're going to get minus 16 meter per second. Okay, and that's the same value as the initial velocity that we had. It's just that it's in the opposite direction now. That minus is important, minus 16 meter per second. Now, the reason that AB is 1.6 seconds and BC is also 1.6 seconds is because when you have projectile motion like this, where you go from A and you come back at C and you're at the same level, everything is going to be symmetrical. So 1.6 seconds, 1.6 seconds, 16 meter per second, minus 16 meter per second. So it's kind of symmetrical. Okay, now all we have to do is just put these points on the graph. So we're going to have 2, 4, 6. It's going to be right over here. 1 is going to be right over here. And then 2, 4, 6. So it's going to be right over here. All we have to do is just connect. And this is going to be our line V. Okay, that's all for this exam walkthrough. Hope you understood it. Now I'm going to show you the mark scheme.